This is the lesson for the study guide for section 1 and 2 of chapter 7 quiz. And so let's take a look at our first problems here. So it says find the square roots. So roots mean that we could have more than one, and that's what we'll see with one of these problems right here. This plus or minus sign means we are looking for two numbers that multiply to make 12.25, but we could either have two positives or two negatives. And here we're just looking for one set of numbers. We're looking for the negative square root, and here we're looking for the positive. So the rule I would go by, since we can't use calculators on this test, is to look for the last digit's numbers. Tell whether it's an even or odd. This is an odd number, and so that means our answer is going to end up being odd. It ends in a 5, so try numbers that multiply to make 5. Like 5 times 5 makes 25. 15 times 15 makes 225, so I know it's going to be bigger than that. And so look for some benchmarks, like for instance 100 equals, square root of 100 is 10. The square root of 200, or not 200, but 400, the square root of 400 is 20, and that means I know that 625 is bigger than 400, so I know the number's bigger than 20, so I'll keep on going. The square root of 900, well, that's going to be 30, and that is bigger than 625, so I know the number's between 20 and 30. I know it's an odd number, I know it ends in 5, so I would go with 25. And so you check, 25 times 25, yes, it does make 625, so that means the answer is 25. Well, here I've got a fraction. So I'm looking for two square roots. The square root of 9, which is 3, the square root of 25, which is 5, and it has this negative sign here, so that means I'm looking for the negative answer. So negative 3/5 is our solution there. 12.25 looks like a really tough problem, but here's what I would do. Find the ones it's between, kind of like what we did here, where I found that the square root of 625 was between the square root of 400 and 900. So here I see that 12.25, the perfect squares that are either smaller or bigger than them are this. The square root of 9 is 3. The square root of 16 is 4. So I know the answer is between 3 and 4. I know it ends in a 5. So it ends in a 5. The number does that I'm dealing with. And I know it's an odd number. Well, an odd number that ends in 5 would try 3.5. So try it. 3.5 times 3.5. We go ahead and do that work, and yes, we do get 12.25. So it does end up working. Now, because of the plus or minus sign, we need to have that plus or minus sign in our answer. So it's going to be both the positive and the negative, and those are our two numbers. Here we're trying to evaluate. So this 3 right here means we're multiplying by the square root of 36, which is 6. And so I follow order of operation. I did the radical first, then I multiply, then I subtract, and that's how I got 13. Here it says the area of a square game court is 64 square feet. And so that means since it's a square, that means both sides are the same. And so it's asking what is the length of one side. Well, my formula goes this way. X squared equals the area. And so I know what the area is. It's 64. So I substitute that into the problem. I take the square root, and I find x is 8. And so I've got 8, and then put some units in there. 8 feet would be our answer. Let's take a look at the next few problems here. They're asking for cubic roots. And so when I do this, I have the same sort of rule. I have, well, if it's an even number, I try even numbers, and I try some benchmarks. And so I know the cubic root of 8 is 2, and I know the cubic root of 1,000 is going to end up being 10, because 10 times 10 times 10 makes 1,000. So I see that 216, it's much smaller than 1,000, so it's going to be closer to 2 than it is to 10. And I know also, and actually it could be right in the center, because when we start multiplying, the numbers get much bigger. But I also see that it's an even number. And so I'm not going to try 4, because I remembered that the cubic root of 64 is 4, so I'm going to try something bigger than 4. And so the next number that I could try is 6. So I try it. 6 times 6 is 36, and then times by another 6. Well, that's going to give me a 6 at the end. That's looking promising. And so that gives me 3, that's 18, and 3 makes 21, so that works. And so 6 would be the answer there. So this is going to be a negative number because 3 negatives multiplied to make a negative. And so I know it's bigger than 6, and I know it's odd. And so again, that tells me that I'm going to try maybe a 7. And so I know 7 times 7 is 49. Multiplying out 7 and 49, you do get 343. So the number is -7. So same thing with square roots. We can have a cubic root that is a fraction. You just take each separate. Cubic root of 1 is 1. Cubic root of 27, well, that's 3. And so those are the answers, 1/3. So on this one, we want to evaluate, and the cubic root is going to cancel out the cube. And we'll see that because if I take the cubic root of -64, I end up getting -4. But then I got to cube that answer, and so that's going to bring me right back to where I started from. So that's kind of what they're pointing out to you here, is that when you have a cubic root, it's going to cancel out a cube, something to the 3rd power. And so now I just have -64 and 43. Make sure you subtract these two numbers, and when we do that, we end up with 21, -21, because there's more negatives than positives. Here it says the baseball display case is in the shape of a cube. Find the side length S of the surface area if the volume is 520 or 512 inches to the 3rd power. So the volume of a cube is just, or any rectangular prism, is length times width times height. Since all of them are the same, it's going to be S cubed. And so S cubed, let me get that a little bit neater. So S to the 3rd power equals the volume. So if I just take the cubic root of the volume, that's going to end up giving me my answer. So the cubic root will cancel out the cube symbol. And so I need to take the cubic root of 512. And when I do that, I see that, okay, it's going to be smaller than 10 and an even number. And so I'm going to try 8. So 8 times 8 is 64. 8 times 4 is 32, and that ends in a 2, so that's promising. So that makes 3. 48 and 3 make 51, so yes, it works. So 8 is the side length, 8, and then these are inches. But that's not our answer. See what they want. Find the edge length S and the surface area. So we got 2 parts to this problem. So edge length S is 8 inches. The surface area, well, the surface area, there's 6 sides to any rectangular prism, 6 sides to a cube also. And so what we're going to do is we're going to take the one of the sides and we're going to multiply it. 8 times 8 is 64. That's one side, 64 inches squared. So this is one side. And then I'm going to take the 6 sides and multiply it by 64. And that's going to give me my surface area. And so when I do that, I end up with 384 inches squared, and this equals the surface area. Well, let's take a look at our last 3 problems. On this one, we have an equation to solve. So we're going to distribute -3 over these 2 numbers. And I have -3n minus 18 plus 10 equals -8. So we continue on. And I see that when I subtract these 2 numbers, I get -8. And here's where people get a little confused, because when we go ahead and add 8, we get 0. And people want to say, oh, there's no solution. But there is. You see, we have the variable term. It's only when the variable term cancels and we have 2 numbers that do not equal, that's a no solution. Infinitely many is when the 2 numbers do equal. But we do have a variable, so we need to continue to solve for that variable. And so I see that 3 goes into 0 0 times. And so it says check the solution. Let's check it. -3 times by 0 plus 6, and then plus 10 equals -8. See, this is 6. 6 times -3 gives me -18, plus 10 gives me -8, and that matches. See, we get an identity, and so I know this is the right solution. Well, here we have the graph, so we're going to start with that y-intercept. Go up 3 spaces, put a dot there, and use the slope. The slope is -1 to 1. And so when you don't see a number out in front of x, it's 1. Minus sign in front means it's a negative 1. So that means down to the right, not down to the left, down to the right, because only one of those numbers is negative in order to keep it as a negative slope. And so that's what we end up seeing there. So the last problem here, it says the landscaper buys 4 peonies and 9 geraniums for $190. And so what we're going to end up doing is we're going to start with, alright, so we have 4 peonies and 9 geraniums for $190. Another landscaper buys 5 peonies and 6 geraniums for $185. Right, and solve an equation to find the cost of 1 geranium. So let's go ahead and set up some variables here. And we'll say P is the cost of 1 per peony, and then just gotta get a Y in there, and then we'll say maybe G equals the cost per geranium. And we'll go ahead and set it up. We got 4 of those peonies and 9 geraniums, cost $190. And the next one has 5 peonies and we have 6 geraniums, cost $185. And then we'll go ahead and solve. Now we want to solve for the geraniums, so that means we're going to cancel out our variable P, and I'm going to multiply by a number that will end up doing that. So I'm going to multiply the top equation by -5, bottom equation by 4, and let's see what we get here. Negative 20P minus 45G equals, and then I've got 0, 45, carry a 4, and that makes 9, so negative 900. And actually, let me go ahead and fix that. It should be 50. So let me get an eraser in here. And so negative 950. And then over on this bottom portion, we have 20P minus or plus 60 or 24G equals, and then when I multiply 4 times 185, I get 740. So when I go ahead and add these together, I end up getting negative 21G equals 210. Negative 210, that is. And so when I divide by negative 21, I get the answer. G equals, and then I end up with 10. So $10 is the cost per geranium. And so that's what you're going to end up seeing on this week's test. Good luck.